Well, hello, explorers, and welcome to another episode of the Exploring Your Universe podcast. This is DJ Stellar Cloud, aka Megan, and I am joined here today by
DJ Swan.
Awesome. DJ Swan, also known as Emmanuel, is a program manager in the Earth, Planetary, and Space Sciences department here at UCLA, and also the Mechanical and Fabrication Lead on ELFIN, a satellite program run by students. ELFIN is highly awarded and a 2024 NASA Tech Leap finalist. So let's just get started. ELFIN has a booth at EYU, and you are in charge of that booth. Could you tell us what happens at the ELFIN booth?
For sure. So ELFIN was a satellite that was built by students, and it was used to study the interaction of the sun and the Earth's magnetic field. So all of that is really cool when it erupts as the aurora, or you see pictures of the sun with solar flares. However, we study everything in between, and all of that's invisible. So our job is a lot harder in that we have to convey all the complex science and the really interesting stuff that powers the aurora, but you have to make it tangible. So my goal over the years has been to find different models. So we have 3D magnetic field viewers, plasma globes, even built a plasma chamber called the aurora in a jar, where you can actually see two spheres that represent the energy between the sun and the Earth. So our goal is for people to come up, ask questions about Earth's magnetic field flipping, asking about the magnetic poles shifting, when is the best time to see the aurora, what can happen when a solar flare hits Earth, are we going to be affected? And for the most part, we're safe, and I just explain kind of the science and why it's interesting, but now that we're more of a spacefaring society than ever, and we depend heavily on our space assets, especially now people with Starlink and GPS, communications, all that sort of stuff, sending people to the moon, we have to understand the space environment. So when people come away from the booth, I hope that they realize there's more to space than empty vacuum, and that there's lots of churning particles and radiation that we have to understand. And it's also a really important part of Earth science, understanding the Earth system, understanding how planets form, how life can form, how water is formed from the sun and solar wind. So there's all these different concepts that could be tied in, and it's just been handicapped because it's invisible.
Okay, so that was a lot.
Yeah.
ELFIN is super cool. First, what does ELFIN stand for?
Sure. It's the Electron Losses and Fields Investigation, and it's a pair of two satellites that launched in 2018, and they were in space to 2022, built by 350 to 400 students.
Wow.
And it collected particles from Earth's environment, electrons and ions, that get accelerated. And so those are the particles that rain down in the atmosphere and create the aurora. And we also built a fancy compass, magnetic field detector or magnetometer, and that tells us what's going on in Earth's environment, whether there's plasma waves or vibrations in the magnetic field that can cause these particles to get knocked out of orbit.
Okay, so that was a lot of really complicated science. I do like how an entire GE course was involved in this. I love the student involvement aspect. And so it's catching these particles, but the particles are invisible. How can you tell when you've caught an electron?
So we basically have two eyes on the spacecraft, one for electrons and one for ions. So they basically are sweeping, spinning in space. So most satellites are fixed and they point in one direction, telescope or whatever, but ours are spinning so that they can scan particles coming from all different directions. So when the particles enter our little telescope, it's basically a tube. The particles go in, they hit a little silicon detector, and a charge is deposited. So we can count the particles, and depending on our orientation, we can tell where they came from. So we know their energies, their trajectory, and that tells us whether or not they're going to hit the atmosphere and form the aurora, or if they're just kind of minding their own business, or if they're doing other stuff. And that's kind of the important thing about ELFIN, is that we have 50 papers that have shown behavior of these particles around our planet that no one else has shown before. So it's really exciting for a student-built project to have such a high science return.
Yeah, absolutely. I mean, 50 papers, your H index is right near Hawking's. Yeah, okay, so ELFIN's sort of like a stopping point for these particles in the ionosphere or somewhere else?
It's above the ionosphere, so
Okay.
This is just upper ionosphere, the edge of space.
And then you can tell us whether or not the particles are going to join the aurora or go somewhere else. Okay, so how do you explain this to children? I'm assuming our viewers are mostly going to be like people my age, maybe undergrads,
Right.
but at EYU, we're talking to people K through 12. They may not know what electrons are. Maybe they've seen the aurora borealis, but probably they don't know what causes that. How do you start to like break down from satellite to aurora?
So the first thing everyone kind of is familiar with is where is north, and we use a compass, so we know that Earth is a giant magnet, and it's important to be able to see what that magnet looks like, and that shape, basically it forms a donut around our planet, this magnetic field or field lines that create a loop from the North Pole. A loop comes out and then enters into the South Pole. So we have this donut protective bubble around our planet. And then I like to explain how we basically have a fancy compass on ELFIN, and it orbits over the North and South Pole, and it can detect changes in the magnetic field strength or vibrations in the field. So I can show that with a little model, and so kids can do that themselves and see how the little compass moves depending on where you are around Earth, and if Earth's magnetic field is shaking, then the little compass shakes.
Wow.
So it's a connection between particles in space and that are coming from the sun and particles that are around our planet and how they commingle. So that's the first step, and then the next step is to show them what plasmas look like, which they're basically just really hot gas. And the gas is so hot that it becomes ionized and it glows. So you show them glowing gas in a chamber, and you tell them that electricity is flowing through it. Same thing's happening in space. And so we need to understand that to see how that can affect our satellites and our astronauts.
There's a really funny story about plasma. I went to this conference called the Conference for Undergraduate Women in Physics. I was like 17, and my friends were like, we really want to go to the plasma physics talk. So I'm sitting in the plasma physics talk for an entire hour. We get to the Q&A part. They're asking questions about, topics that you would know about, but I was super confused. And so the thing is about to end. There's 2 minutes left, and they're like, do we have any more burning questions from the audience? And I went, what is plasma? And I remember one of the panelists was like, I just want to tell everybody that this girl is honest. She's going to be honest for the rest of her life. She does not mind like looking like the most ignorant person in the room. So, I've come a long way because I understood everything you just said, which is great. That means I think the kids at EYU are understanding it too. And I'm sure like you have a mini ELFIN or something, or like the real ELFIN is there.
Yes, we have a model, so we can show what the spacecraft looks like. Originally, spacecraft would be like the size of a bus, or the size of a small car or refrigerator. Now they're basically the size of a loaf of bread, and you can fit in pretty much the highest quality instruments now into a smaller package for much cheaper, and you can do it faster. So the whole point of ththese CubeSats, as we like to call them, is to innovate and refine and then be able to develop new technology. So that's the goal of our program. But yeah, a lot of people that are educators or that are at big space institutions will shy away from talking about plasma. And I really disagree, because as soon as you interact with it, it's something that we don't see other than fluorescent light bulbs are filled with plasma. Fire is a plasma, and lightning is a plasma. Beyond that, we don't really think about plasma, but it actually makes up 99.999% of the universe and our solar system. So it's something that I think should be talked about.
You guys can't see my face, but I'm very fascinated by this. This is a really crazy stuff because somebody actually does know what the universe is made out of. It's the plasma physicists, and we never ask them enough questions. Okay, so, I'd imagine you're talking about this with the children. They're also looking at you like I'm looking at you right now. Are there any like special experiences that really stood out to you, like running the ELFIN booth?
Yeah, pretty much just seeing kids like automatically gravitate towards the plasma balls. I know I did when I was really young.
Is that the thing where you put your hand on it? Oh, okay.
Yeah, and so it's glowing inside, and you touch it, and then the little kind of tendrils of electricity try to flow into your hand.
Yeah.
And everyone asks, is this safe? And I have to tell them yes. It's just a demonstration. But the coolest reaction is when you hold a fluorescent light bulb near it, and because there's it's complicated, but I basically simplify it as there's an electromagnetic field around this plasma ball. It can cause the fluorescent light bulb, even held several inches away, to glow.
Oh.
So it almost looks like a lightsaber.
Yeah.
But the point is that you can have electromagnetic fields reacting across a distance. So even though these charges up in space are doing their own thing, they can actually induce charges or currents in our power grid on the ground, or in pipelines and cause them to fail or catch on fire. So the point is that plasmas, because they have electricity flowing through them, they have a magnetic field that they can impact things farther away. So that's why it's important to be aware of how space and the space environment is not just like something separate. It actually impacts us here on Earth.
Yeah, I love those plasma balls. My favorite picture is the cat with its hand on it and the whole paw lights up. So over the summer, we actually had one of these events. There was some kind of solar flare, you can correct me if I'm wrong, and it caused a lot of power outages. My friend Laura May at Griffith was posting about it, and that's why I know about it. But this kind of leads us into your other booth, space weather. So is space weather also caused by these plasmas?
Yes, space weather is the study of space plasmas and how they impact, the energy from the sun impacts the Earth. So we, like maybe 50 years ago, we're just starting to be able to predict terrestrial weather.
Oh.
And so having buoys in the ocean, having aircraft sampling winds at high altitude, now we have pilots that do that, and we have satellites that can measure these things, predict hurricanes, rain, all those things. So early on, the prediction capability was pretty iffy, and so now it's pretty good, and so we can generally trust that it's going to rain when they say it's going to rain. Space weather is still less than 50-50. So if there's a blast on the sun, you have an eruption of or solar flare, which is basically a magnetic field that explodes. And that is happening a lot more now because the sun goes through these seasons or solar cycle, and so there's a lot more of these solar flares. So more than ever, people now are talking about space weather, which is amazing. And this is really my dream come true, is to be able to relate to people why this is important. We send rockets up into space. We're sending satellites. We're sending people. So each one of these eruptions shoots a blast of particles at the Earth. It also will cause our magnetic field to fluctuate, and it causes our atmosphere to heat up and expand. So Starlink satellites are normally launched in a bunch, altogether like 30, 40 of them. So 2 years ago now, almost all of them, I think 30 of them, all burned up because there happened to be a solar flare, solar storm at that time. And so it costs tens of millions of dollars, just poof, gone. And Elon had said, oh, it's like space weather is just an engineering problem. We'll deal with that later.
Of course.
Clearly,
naturally.
Yeah, clearly this is something that we have to think about if we're going to put astronauts on the moon, including potentially a UCLA Bruin, Jessica Watkins.
Woo, Jessica Watkins.
Yeah. So understanding space weather is, I think, necessary at this point in our society and our dependence on technology and Google Maps, drones, automated cars. All of these things depend right now on GPS and communication networks that are space-based.
Speaking of Elon, did you see?
Yes.
Okay, so today is the 17th, and so I think yesterday, was it just yesterday? There was a launch that did not go very well. I don't know that much about it. Did you happen to watch the video or anything?
Yes, I did. What's really cool in ELFIN is that we keep each other aware of different space events. And so, pretty much every significant launch we watch, and we've been tracking Starship and Falcon and all of the different launch vehicles, New Glenn. But yeah, the lower stage was able to land and get caught with the chopsticks, but the upper stage, which would be delivering astronauts or payloads to space, the heaviest, largest capacity so far, and that just burned up. And so far we don't exactly know why. Space is still hard. Even though a lot of the SpaceX launches have been super successful, this is still pretty cutting edge, and until they get all the data, they won't know what happened. And so in the meantime, it's still important to collect this data, even though overall the mission didn't do what it needed to do.
Yeah, my partner is like a huge rocket guy, so he's watching this yesterday, and then all of a sudden I see him Googling Turks and Caicos, and I thought we were going on vacation. Unfortunately, it was just the SpaceX explosion. But anyway, so when you were launching ELFIN, did you think about like how space weather was going to affect ELFIN itself, even though it's sort of a space weather detector? Yes,
absolutely. I mean, there's no way to describe the feeling of having built something yourself and spending thousands of hours, and you watch these launches on TV, it's no big deal, but then yours is actually up and you're standing there in the dark and it's freezing and it's 6 a.m. and you're listening to the countdown. It was super emotional. And so we were worried, like, what if the rocket blows up? What if there's a problem? What if it gets delayed? But thankfully we got into space, and we were only supposed to last 1 year. That was
Really?
the minimum mission was to collect data for 1 year. And just because the sun actually was in a period of lower activity, we got exposed to less radiation, and we lasted over 4 years. Earth's atmosphere wasn't as heated because of solar activity, so the orbit took longer to decay. So we collected data for 4 years when we only were supposed to last one, and so that's how we got so much really good information. So granted, the sun wasn't as active, and we wanted to get some big flares to be able to detect those, and we got a few. Not as many as we'd liked, but that's the goal for the next round, to build another set of satellites, collect more data in this more active time.
I didn't realize that like ELFIN was going to make a return. I started grad school here in fall of 2022. So actually, you were leading our group through like the orientation process. I remember seeing the whole ELFIN thing, and you guys were talking about it, and it was super active at that time. I don't know if you guys were just coming back to Earth around that.
Yeah. It deorbited end of September, so it was right around the time that happened. So all of us were getting reports from NASA, oh, your satellite's decaying, and they tracked it, and so it was like going to crash within, or basically burn up in the atmosphere, turn into plasma.
Okay.
Basically, just like the rocket yesterday.
Yeah.
But none of our satellites survived. They were too small. They just burned up entirely, vaporized. But we all got together because we have our own control room here in EPSS in the geology building, and we watched the satellite late at night the night before, said our goodbyes. And the next morning it was gone. There were no more transmissions. So it was bittersweet.
Okay, so what causes a satellite to burn up?
So you power these gigantic rockets to escape Earth's gravity.
Yeah.
And you speed them up basically tangentially to the force of gravity, so that you're carrying maintaining this altitude through your speed. And so over time, that speed decays naturally.
Okay.
Due to friction with very tenuous gases, plasmas, basically in the upper ionosphere at the edge of space. And so when there's less solar activity, there's less of this friction. When there's more solar activity, there's more of this friction. There's other things that can cause the atmosphere, the thermosphere to expand. But all satellites slow down over time. The closer they are to Earth, the more friction there is. So we knew that our time was limited, and so we were given like better estimates until the very end. It was like, okay, you guys have a couple weeks. Okay, now it's going to be a couple days. Now we know it's going to be sometime between midnight and 3 a.m. on September 22nd or whatever it was.
This is so sad. Unfortunately, it just reminds me of like when people are chronically ill and like passing away. So I can't imagine like all the work that you personally put into this. How long were you working on ELFIN before it launched?
From the beginning. I arrived in 2011. I've been at UCLA for 25 years, and I did cancer research before that, and decided to make a career switch. And just as I joined the space physics group here in EPSS, we got funded for the ELFIN mission, and it was the third time that they'd applied. And so I basically had to help get all the equipment, set up all the labs and the computer rooms and everything to accommodate these 40 to 80 students that we would have every quarter. And at first I did kind of more administrative work, and then over time I got more involved in mechanical design and manufacturing, and now I run the prototyping lab in our department, so we can manufacture things with a CNC machine, including satellites, test equipment, field sampling devices, modify things. So it's really powerful to be able to manufacture stuff, and you can actually make satellites.
I remember walking through the CNC room. It's this huge machine. If you've never seen it before, I feel like it's like 10 feet cubed, like on all sides. And so, I'm new to UCLA. I'm super scared because I'm going to grad school, and that's scary. And then Emmanuel is describing like, this is how you don't die in the CNC machine. And I was like, this person knows how the department is run. If there's ever something like absolutely going wrong, like this is who you need to go to, because like he will help you out of this problem. And I guess what's funny is that your other job with EYU is quite literally that. So recently you became one of our staff liaisons. And this is a very fancy word for doing everything that the graduate students are not allowed to do. Do you have any like funny stories about being our staff liaison?
Basically just the night before EYU, pretty much without fail, no matter how much we prepare, there's always last minute things. So it's kind of a just inside joke to just be like, hey, it's after midnight and we're going to start this event in 8 hours. And here we are, we're getting things done, and every time we make it happen. So it's funny to see the time change.
Yeah.
And you're like, oh, I got another hour. I can stay at UCLA for a little bit longer.
That's right. I forgot. It's always on the
Yeah.
daylight savings time, which is good because we start at 9 a.m. and I normally wake up at noon. And so it's really, it helps. But anyway, so that also happened to us this year. This year, you happened to interface with me on these issues of like, we need furniture and I don't know how to get furniture. But you have been at EYU since way before I have been. So when did you start volunteering with EYU?
Pretty much in 2011, as soon as I joined. Part of why I was hired was that my boss, Professor Vasilis Angelopoulos, a space physicist,
Ooh, Vasilis.
he knew that I had experience with outreach, and I had volunteered at the Natural History Museum, designed exhibits. I was good with telescopes and microscopes and different equipment. And so naturally, he's like, we have this event. Like, it would be great if you could represent our missions, which we have 5 other satellites called Themis Artemis.
Okay.
I won't go into that, but you can Google it, NASA Themis Artemis. And so I showed the satellites, and I had a projector, and I was showing the aurora and the sun, and I had some rudimentary magnets.
Yeah.
And so it started off very humbly.
Yeah.
But we got a great response. People were really fascinated to know that UCLA professors and scientists are actually working on active missions, and that we develop hardware that goes to other planets, including the Europa Clipper, which is going to Jupiter now. It's passing by Mars, actually, I think this week or next week. And that we have scientists also work on Parker Solar Probe going to the sun. Galileo, which went to Jupiter. We have a magnetometer, a magnetic sensor on the surface of Mars. We have various satellites orbiting the moon. So there's so much cool stuff that's going on here. But so that first EYU, we basically just had fun talking to the public. And then the next year I was like, I want to make more posters, more like hands-on stuff. Develop my own demonstration. So that's when I built the Aurora and the Jar. And so that was a big hit. And I like to take that to schools. I'm taking that to elementary school next week, actually.
Yeah, I mean, thank you for doing that. As somebody
sure.
who benefits heavily from EYU, I mean, when I got here in 2022, I was like, this thing is so official. And then the more and more I learned about it and the more I got involved, I was like, oh, it's actually just like a few people in Emmanuel. And we kind of like hold this whole thing together.
That's true.
But yeah, okay, so you've been doing this since 2011. In 2011, it was just like you and some posters. What was EYU like back then, even like 10 years ago?
It's hard to remember. I know a lot more of it was indoors, and there were booths, and it was mostly the astronomy and physics, astronomy, and Earth Planetary Space Sciences, chemistry. Maybe AOS was involved, but it was mostly space stuff. From what I remember, some chemistry stuff. Over time, more departments have been represented.
Yeah.
There's outside like different people with telescopes.
Yeah.
Different institutions. Other educational groups. So now it's really become a bio also has been much more represented. So it's basically everything STEM, and it's a wonderful open house. And yeah, as a kid, I went to the planetarium a lot. My mom took me to museums, and that was my refuge. And I just wanted to know as much as I could, go to the library, check out all these books. So I feel like these types of events, it's basically a springboard. You get exposed to something. Kids get really inspired and motivated, and they want to learn all about it. They can ask questions without feeling intimidated. Like if you go to a lecture, you don't want to raise your hand, but you were brave enough to. But when you're just talking one-on-one with a researcher or a professor, you can kind of let your guard down and just ask honest questions, pick up even the exhibitors. I learn a lot from people. Like they bring up things that they heard in the news, or they know someone that knows someone else that's at SpaceX and they heard this. And so it's a really great exchange, not just top down, but we learn a lot from the visitors, and it's really, really rewarding. And when you meet people that are accepted as students and they said, I went to EYU 6 years ago, and now I'm a student here, and I've always wanted to come to EPSS.
That's so good.
Yeah, it's amazing. It's really, really a great feeling. And I know that a lot of students don't get access to universities or university education, or they don't know that they could go into space science or research, and they're like, oh, astrophysics, that's too hard. And that's how I felt, honestly. I wasn't that prepared in math and physics, so I kind of discounted it, and then here I am. So I'm trying to explain to other kids, you can do like other aspects of space that aren't like physics engineering. I mean, there's all sorts of like administrative roles, technical roles. You can get involved in space medicine, space law. There's all sorts of different avenues now that space has really hit the big time in a sense.
Yeah, absolutely. And we'll definitely get more into like your personal story after the break. But okay, so with EYU, this whole episode really sounds like a huge advertisement for UCLA. I had no idea that we had all these missions, and you have now exposed the public to like the plethora of really cool science that UCLA is doing. Do you remember any like super excited responses, or somebody told you like, I'm going to apply to UCLA because of the things that you told me?
Yeah, absolutely. I've met 5-year-olds like wearing astronaut uniform, and they're like, I'm going to UCLA and I want to be a scientist here. One of my good friends, Dennis, he's at Toluca Lake Elementary. He was an alum from UCLA, and we happened to meet at EYU. And so he had me come to his classroom every year. I've done planetarium shows and various events with them, star parties. And he tells his students, like, where are you guys going to go to school? And they're all like, UCLA. And getting to connect with them and explain all the cool stuff that we're doing here that's right in their backyard is really, really great. And there's just so much amazing stuff all across campus. I mean, I don't think I could have switched careers anywhere else that would have had as much of an opportunity for crossover. Just the constant sort of innovation, involvement in all different areas. So I think that hearing about like getting your hands on actual satellites, especially with students, talking to the students that are maybe 10 years older than some of these kids, or less. And they're like, how do I get involved? And I'm like, well, start learning how to program, start learning about different, like 3D printing and all these things. And there's so much information online now. You can explore and see what careers are like. And instead of just taking a shot in the dark and being like, oh, I'm just going to be an engineer, but I don't know what yet. So now you can actually interface with people that do the job, ask them what they like about it, what they don't like. And I think that's really important for people young people to do.
Yeah,
really.
So I really like how your approach to EYU is like, I'm going to bring the plasma ball so that, if you're 5 years old, put your hand on the ball. But if you're a little bit older, here are some really practical skills that you can start working on so that you can have a career in space later on, the programming and the 3D printing and stuff like that. I didn't know I needed to know how to program until third year of college. So it's really great that you're telling people who are a lot younger than third years in college. So EYU gets like 10 to 12,000 visitors a year right now. How did it start? Do you know?
I remember it was in the couple thousand still. There was a lot of people because we did get a really good promotion through the newsroom.
Newsroom, go Ben Paul.
Yeah, for sure. He's been a huge help with getting the word out. But I remember, kind of rough count. I think the first couple years I talked to 300 to 400 people.
Wow.
And since then, pretty consistently 700 to 1,000 people come through our room. At any given time, there's like 30 to 50 people in there.
Wait, how do you count that? How do you count that?
I try to estimate, since I've been doing this for such a long time, people tend to stay in the room 5 to 10 minutes.
Okay.
So at any given time, there's 30 to 50 people. So I just extrapolate kind of over time. Over an hour, there's maybe 50 to 80 people per hour over 5 hours at minimum. Yeah. And then you have higher turnover at certain times. So in the above 500 to 1,000 easily.
This is extremely important information. People ask me all the time how many people are going to come to their booth, and I have no idea. So I'm going to refer back to this episode. This is not only the advertisement, but it's like the informational episode, because Emmanuel knows how things go in this department. So he's going to be able to estimate how many people are coming to your EYU booths next year.
Yeah.
Okay, so that kind of is going to conclude our EYU section of this. Any final thoughts on what it's been like being a part of EYU, seeing it grow?
Just the sort of following that we have. Even after COVID, we were like, what's going to happen? Are people going to come? Are they not going to come? And then we ended up having another record year. So people in the community definitely look forward to this event. They have it on their calendar. They tell each other. And it's basically its own institution, which I'm really, really proud that we've created that level of awareness and expectation that we're going to top it every year with great speakers, with lots of hands-on stuff. And then, kids that are coming every few years, they get exposed to more things, they ask more advanced questions. I start to recognize people. I remember you from last year.
Oh, wow.
Yeah, and it's really cool. They come, they see the couple new things that I have, and they tell me, that's so cool, you added this extra stuff.
That's
and
so
like,
cool.
Yeah, no, it's awesome to have a relationship with people that
Yeah.
you otherwise wouldn't get to talk to very much, or they go to a museum and they just stare at a
Yeah.
poster or a description, but now you can interact
Yeah.
one-on-one. It's
Yeah.
wonderful.
Talking directly to the scientists. That's
Yeah.
what we're doing now, and
Yeah.
we've expanded to the radio show now.
Yeah, and not just the scientists, the students that
That's right.
volunteer
Yeah.
get to explain what they're working on, and I
Yeah.
think that's as important as what they're learning in classes, to be able to explain it, to be able to synthesize and summarize, and be able to defend what they're doing to people that don't know the jargon, because that truly means they understand what they're doing and they can explain it at different levels.
Yeah.
So it's also for recruitment, obviously, but yeah, I think it's a great all-around experience for everyone.
Wonderful. And with that, we're going to listen to some music now. When we used to air on the radio, we would listen to some music now. But since you're streaming, for copyright reasons, we will not. But you're welcome to pause here and go listen to some songs. Okay, cool. So welcome back to the EYU radio show. We just heard some really great music. Do you want to tell us about your music choices?
For sure. The first song is a piano piece that I played as a really young kid. And yeah, most Asian kids are forced to play piano, and I didn't enjoy it at the time, but it definitely set me on the path to explore more music, which I'll get into later. So I play a ton of different instruments and love all sorts of music. But the first piece is called Rêverie, which means dream in French, by the composer Claude Debussy. So I think I was about 8 or 9, and I was in a lot of competitions, and so my piano teacher was asking me, what do you want to play? And I'm like, I don't know. And so he was just playing a bunch of like kind of standard classic Mozart, Bach stuff. And then she kind of came across this piece, and it was really dreamy, and I remember feeling right away like, this is my inner world.
Yeah.
Like this just so like ethereal and like kind of like dark and light and like basically like clouds changing. And ever since I was really young, I was always a cloud gazer, unabashedly. And so that feeling of basically floating and kind of having emotions wash over you, I immediately fell in love with that song, and so I played that in a recital. And so every time I hear that, it kind of makes me think of like space and plasmas and the natural systems kind of ebbing and flowing and intermingling with each other. And yeah, just sort of like life, ups and downs, like positive and negative, just sort of everything all at once.
Yeah, I was also a piano kid. I'm more partial to Mendelssohn, but that never happened for me. I'm waiting for piano to make it back into my life. I'm still mad at my parents for making me practice. So, I mean, props to you for, like, moving past that. Do you want to talk about our other song, too?
Sure. That one has a space title, Stardust. It's really just a love song, but I love Nat King Cole. He's got a beautiful voice. He actually lived in L.A., back in the day, and faced a lot of hardship living in Beverly Hills as the only black person there. But that song in particular just has this longing quality and just beautiful chords, and I love the melody. Pretty much all of these popular tunes came from Broadway, so I don't even know what the show this was from. But that song always just stood out to me, and I liked the name Stardust. It just sort of has a sort of evening quality. The sun is just set and the stars are twinkling, and you're just sort of feeling this like kind of warmth and sort of just longing. That's sort of the what I get out of it. Yeah.
Are you a water sign? Like, what is your astrological...
I am a water sign.
Oh my gosh, I clocked you.
Yeah, I've never been into the horoscope stuff, but yeah, I'm an Aquarius. My birthday's actually in a couple weeks.
That's so bad. Aquarius is not even a water sign; it's an air sign.
Is it an air sign?
Yes, it just has aqua in it. But
okay, I didn't know.
It's air.
But yeah,
it's okay.
Goes to show.
Now you know. Well, happy birthday.
Thank you.
But also we can get to know you a little more. DJ Swan. Why'd you pick DJ Swan? And then just like, who are you? How did you get here?
For sure. So my avatar has always been the Swan, because in high school, people didn't like saying my last name, which was Masongsong.
That's not even difficult.
It's not, but yeah, people would mispronounce it, make fun of it, whatever.
Okay.
So my closest friends kind of shortened it to Song, and some shortened it even to Song.
Yeah.
And so like basically I can tell what era my friends are from by what they call me. So my family also has a bunch of different nicknames for me. So I've always had nicknames.
Yeah.
One day, one of my friends changed Song to Swan Song.
Yeah.
Which came from Led Zeppelin. It's also from this metal band called Carcass. But then that got shortened to Swan. And so, yeah, it kind of stuck with me. It sort of represents a lot of my personality. I'm like fiercely protective, very serene at times, but also like adventure and exploration. I like to travel. I'm in the air, I'm in the water.
Oh, yeah.
So I felt like that really suited me, and I really enjoy that name. So my really close friends call me Swan.
Oh, okay. That's a good one. It always makes me a little bit sad when people with, and I hate this word, but like ethnic, non-English sounding names, like give themselves nicknames. But I do like that you've sort of like reclaimed this part where like people didn't want to pronounce your name, which again, Masongsong, not too difficult. That's like 3 English words. But like now it's like something beautiful and you're like, this really represents me, and it's your Instagram handle.
Right.
Yeah. Okay. So what is Masongsong from? Where are you from? I have no idea.
Yeah. So both my parents are Filipino. My mom was born in the Philippines, came here in the early 70s. Her mom, my grandma, was a nurse. So I'd only learned in the last few years about this whole program of bringing Filipinas specifically to recruit for the nursing force. And so, yeah, I grew up coming to UCLA all the time. She was in immunology here, so she gave students shots. Okay. So she'd babysit me. I'd like chat and joke with the students when I was like 3 or 4 or something. And so she'd be injecting them, and I just like hang out in the room with the students. And so I came to UCLA all the time, saw the inverted fountain, walked around at lunch with her. And so when I was in high school, I vowed I didn't want to go to UCLA because I'd been here so much, but then I ended up staying here
of course,
a couple more decades, and I'll probably be here till I retire. I grew up in Santa Monica, and so my grandma just happened to come to Santa Monica of all the places that she could have chosen, and so I've been based here my whole life. And then went to elementary school in Santa Monica, went to Loyola High School, all-boys Jesuit school, and went to UCLA. I had to choose between going to Berkeley for electrical engineering, computer science, which I heard was really steep. Really tough.
Oh, EECS.
EECS, yep.
There's so many memes about EECS on UC Berkeley, memes for edgy teens.
Right.
Yeah, so I do know about them.
And then I was also pre-med at UCLA, and I was kind of wishy-washy about which one, and I was in a band at the time, which was touring, and I was in a relationship, and had my friends and family here, so I ultimately decided to stay here, which I'm glad I did. Because being at UCLA was an incredible experience. I took 5 years back when you were allowed to, so I actually took a ton of electives. I took a bunch of music courses. I was in choir. I was in an Argentinian tango band.
That's so cool.
I took music psychology and acoustics and just all sorts of really cool stuff on top of virology and all the med courses. I was at MIMG, which was unnecessarily hard. So I kind of felt that because I'd spent so much time in college studying medicine, like cancer research, I worked on HPV and HIV, doing clinical research, which was great working with patients, but I did also spend a lot of time in the lab pipetting fluids for days at a time, and that like pretty much wore me down. Yeah. So I basically was like, I need to do something else. I volunteered for a while at the Natural History Museum, thinking I wanted to get an education. I was thinking of going back to school, studying music education, and then the 2008 crash happened, so that basically was out. So I volunteered, got good at developing exhibits, and then I just kind of tried to find different random jobs, and ended up working for Vasilis. And because education and interfacing with the space community and doing press releases and website development, graphic design, and then now we're actually developing a program of turning space plasmas into sound. Oh. And so I feel that that's like...
It's right up your alley.
Right up my alley.
Built for you.
So, so I joined the department in 2011, and then got involved in ELFIN, as I mentioned. And my first reaction when I got the job was, how did I not know all this cool space stuff was happening at UCLA? Like, I had no clue.
That's my first reaction recording this episode, so...
Like, I was taking, I had a organic chemistry section on the top of geology, and literally around the corner, there was all these scientists developing space instruments, sending missions to the moon and Jupiter, and I just had no clue. And part of that is that you go on tours, and they talk about the internet in the basement, and the med school, and blah, 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 the physics department and space. But they just tell rock jokes in front of the geology building. And it's really, really sad. And I tried to get that changed because people, I think, miss out on how powerful this sort of interdisciplinary aspect of planetary science, geology, earth science, environmental engineering. There's so many applied physics and engineering things that can be done in our department. And so it's also really important to me, since I learned about all this and now that I work here, to also spread the word about that. And so EYU is part of that.
Yeah.
Also getting more information about our majors and going camping and being part of this community in EPSS, which right away I felt drawn to. It's really like a family here, and it's been such an amazing experience for me. So I've been here 13 years now. I joined the day after my birthday, so it'll be 13 years in a couple weeks.
Wow.
Anniversary here in EPSS. I've been really, really happy with the variety of things I do. From everything from writing grants and mentoring students, doing events, playing music in the band.
Holiday band.
Yeah, hanging out with people after seminar, getting to attend all sorts of amazing lectures.
Yeah.
Going on field trips. Like I got to go on a geophysics trip and learn about seismic measurements and magnetic measurements. This was Mount Whitney area, the Sierra Nevada, Owens Valley, which is one of my favorite places, by the way, to go camping. It's incredible. I mean, being in California is just so many amazing natural places. So people that are in LA that come to UCLA, I tell them, leave the city. Like, go check out Joshua Tree, go to Sequoia, go to Yosemite, check out Anza Borrego Desert, see the coastline. There's so many amazing things to see here, and UCLA science is infiltrated all of them. So it's a wonderful place to be, especially in this department.
This is like the best advertisement for UCLA I've ever heard.
I mean, can't help myself.
I know, it's so good. It's so nice to talk to somebody else who just like loves the university like I do. I also have this like deep love for the university because I'm a third gen Bruin, and it's always been decided I was gonna come here. And so I just can't imagine you going from the little, like the funniest toddler ever. I can't, like, you're getting a COVID vaccine. This toddler is just like cracking you up. Imagine yourself, this very funny toddler, is somebody going to EYU. What would you have wanted to hear from like the people of EYU?
Basically that whatever I choose, since I like science, that it's a similar set of skills across all of these different fields. And so just basically learning about yourself. What do you like? What do you enjoy doing? Like, do you like hands-on stuff? Do you like computer stuff? Do you like drawing? Do you like talking about it? And I liked all of those things, but I really just didn't know how to apply them. And my mom was a single mom. She worked.
Ooh, single moms.
Yeah, she didn't really know, other than museums and planetarium, how to give me these sort of exposures. And so when I got to high school at college prep, freshman year, there were students that were already in AP Bio, AP Calculus. I was like, what?
I know.
How did I not even, like, I didn't even know I could take classes at Santa Monica College or community college. So
it's crazy.
So I tell kids, like, if you're really into this stuff, take classes. Go on to Khan Academy, take LinkedIn Learning. You have all these resources, watch these videos. I mean, as long as they're legitimate and fact-based. And there's more reputable ones, of course, but
we're making one now. It's great.
Yeah, right on. And so like getting access to all this content, basically knowing yourself and knowing what you like will, I think, lead the way. Because if you choose the topic and you commit to it, and then you start to get these kind of red flags and like, I don't know if I really like this, but I've already committed to it, I'm already in debt. You don't want to be in that spot. You want to choose something that you're passionate about and make your passion your job, because your career really shouldn't be, I need to make money and I'm going to suffer through this. Like, at least that's how I feel. Some people can do that, but I can't. I'm passionate about so many science things that this is one of the best ways I could have found, I think, to mesh all of these things together.
Well, those people are not here in an academic institution. So, well, we'll just end with, like, what are you passionate about inside of work, outside of work? What does it mean to be Emmanuel Masongsong in the department? I don't even want to, like, say your job title, because you're so much more than the job title here.
Thank you. I guess just, being a resource, being compassionate to other people that are going through various things. And I know with the fire, with COVID, there's so many people just have, like, their own struggles. And in the midst of it, they're also pursuing their education. They're also pursuing research. They're also doing internships. They're also trying to have fun. So I guess I like to be a facilitator. I really enjoy making my group feel welcome when they come. Visiting researchers, lecturers, all these people that come here. I want them to know how amazing it is in this department, how great it is to be in California and the natural environment. And I've also, through COVID, my hobby that I picked up, I got a VR headset and started doing Vader Immortal with lightsaber and threw out my shoulder. And so I was like, I got to learn how to like wield this thing. And so I fell into historical European martial arts.
Excuse me, what?
So I started learning sword fighting from Germany in the 14th and 15th century. Then got into rapier, dagger, spear, all these different things, and started learning this. And now I can actually say that I can teach it. And I've mentored 3 students to apprentice level, and it's great exercise. It's awesome to learn about the history and really understand the medieval life and not just what's in movies, because unfortunately, once you learn how real swordsmanship works, you watch these movies and they're kind of a joke.
Like The Matrix or whatever.
Yeah.
I don't even know what has sword fighting. I don't watch movies. But there is a really funny tradition from Europe where people who get their PhDs get a sword with it. So there's a lot of potential customers for you here. I'm too clumsy, so...
Yeah. Professor Jewett is notorious for knighting his students. Yeah, no, it's really cool. But yeah, I got into that. And then I also got into drones. And building them over. And so, yeah, the opportunity to develop hardware and work with the UC drone office to help them develop standards and training. I trained various lab groups to do mapping, how to fly these remote controlled things, because it's a lot harder than it looks, because you can have it do automatic stuff, but if you're trying to do more advanced terrain and complicated mapping stuff, then it takes a little bit more skill. When I was in undergrad, I actually was I was always obsessed with airplanes. But undergrad, I got my first credit card and I immediately used it to pay for flying lessons. So I would ride my bike to Santa Monica Airport, fly over Malibu, and do all these maneuvers, and then ride my bike to campus, take classes. And so I did that up until I got almost got the certification. I just ran out of money. So now I just fly in VR. It's still super fun.
Nice.
And then I also play a lot of music. Like I'm in the holiday band. I was in the UCLA chorale. I learned Indian music here at UCLA, which was an elective, and so I studied sitar and tabla, and got to perform as a student, and then became friends with the visiting professor, Ustad Nishat Khan, and I recently got to perform with him and an orchestra in Oman, in the Middle East, a couple months ago. I've performed all over Europe, all over the U.S., and then he's debuting an opera in London at Grange Park, the sitar opera of the Taj Mahal. So I'll be
This is insane knowledge. I feel like my brain has expanded 3 sizes listening to you talk about this stuff.
So I'll be in London this summer. So I'm grateful to my boss. He lets me travel. I can do these performances. I do like tour stage managing, and some performance. So I try to get my hand in everything. It's hard to say no.
Yeah. For fun, can we list all the instruments you can play?
Okay, I guess the ones I'm best at would be guitar mainly, bass, drums, saxophone, vibraphone, banjo, all sorts of hand percussion, djembe, rick, darbuka, and then I got into bagpipes, shakuhachi, didgeridoo. I'm building a hurdy-gurdy now, so I'm trying to get into medieval instruments.
My boyfriend's also building a hurdy-gurdy.
Hell yeah. No, we're
out of space.
We got to connect. I'm about halfway done. And then, singing. I do music engineering too, recording, keyboard stuff, like electronic music. But yeah, right now, mostly I'm focused on percussion, jazz, drums, and saxophone. So yeah.
You do everything.
It's hard to say no, like I said.
Okay, so we're running out of time here, but what is one last thing you want all of our listeners to hear?
I guess that because we have access to so much information out there, don't ever tell yourself, oh, it's too late, I missed out on music, or oh, I wanted to study astronomy. There's you only live once, so just go for it. Ask someone, like, how do I get more information? How do I get interested in this? What kind of courses should I take? I want to change my career. Like, how did you do that?
Yeah.
Don't be afraid to ask questions. There's no stupid question, and you never know. the one sort of bit of information you get may completely change your career trajectory, and you'll never look back.
Okay, so if people wanted to ask you questions, could they do that, and how and where?
Sure. You can either email me at swansong@ucla.edu, which I scored when I was an undergrad.
Beautiful.
Or visit the ELFIN website, elfin.epss.ucla.edu, and you can contact me through there, learn about our satellite. I'm also on Instagram, swansong_.
Cool. Well, thank you so much for joining us. I learned a lot about ELFIN, space weather, and like how to be a person. I'm looking forward to the day when I forgive the piano for what it's done for me. But yeah, I'll see you around the department. Thanks so much for being here.
For sure. Thanks for inviting me, Megan. Had a great time.
Yes. So with that, never stop exploring. It's not too late.
For sure.